This is a slideshow about alkenes, and in particular, the types of reactions that's typical of them, addition reactions. Addition reactions involve unsaturated hydrocarbons that can include alkenes and alkynes. In an addition reaction, the double bond between carbons is replaced by a single bond, or in the case of alkynes, a triple bond replaced by a double bond, and so forth. In this particular reaction of ethene with chlorine, one of the chlorine atoms will end up on this carbon of the double bond, and the other one will end up on this carbon of the double bond, and the double bond will become a single bond. Here's another example. In this case, bromine is being added, similar to chlorine. Again, we see double bond between the carbons becomes a single bond. Let's try another one. This time it's propene, which has 3 carbons in its chain. Again, 1 CC double bond. So one chlorine gets added to one carbon of the double bond, and the other chlorine gets added to the other carbon of the double bond, and the double bond becomes a single bond. You can also add hydrogen to an alkene. Now you need special conditions for this. It has to be a high temperature of 300 degrees Celsius, and you need a nickel catalyst. You'll see that the hydrogen atom is added to a carbon, each carbon of the double bond. You can add a hydrogen halide, for example, hydrogen chloride or hydrogen bromide. In this case, hydrogen is added to one carbon of the double bond, and chlorine is added to the other carbon of the double bond. Again, the double bond becomes a single CC bond. This is what it looks like. Molecules reacting, bonds break, new bonds form. And what was an unsaturated molecule is now saturated. We formed a saturated haloalkane in this case, a chloroalkane. You can also add water to an alkene. Now it's best to think of water as a molecule containing 2 groups, hydrogen and OH, which is oxygen, hydrogen. So then we can see that when we have an addition reaction with water, the H ends up on one carbon of the double bond, and the OH ends up on the other carbon of the double bond. For that reaction, you also need an acid catalyst. Now, often you get 2 products. You get a major product and a minor product. What that means is the major product is produced in bigger quantities than the minor product. There's a rule that helps us to work out which is the major and which is the minor. It's called Markovnikov's rule. And this states that the carbon of the CC double bond that has more hydrogen atoms gets another hydrogen atom added to it. Here's an example. So we have propene reacting with water with an acid catalyst, and we get 2 products, major and minor. Let's look at which is the richer carbon. This carbon here has 2 hydrogens attached, whereas this one only has 1. So therefore, that's the richer one. So that'll be the major. That'll determine what's the major product. So the hydrogen from water will end up going to that one. Okay? And the OH will go to the other one to make the major product. The minor product, these will be reversed. But here's the major product forming. water approaches the alkene double bond, bonds break, new bonds form, and there we end up, in this case, with the major product. That's called a secondary alcohol. Do you remember why it's called secondary? It's because the OH is attached to a carbon that's also attached to two other carbons. Okay, that's why it's secondary. And here's the minor product forming. Remember, it does form, but just in lesser quantities. So again, bonds break, new bonds form. There's your minor product. This is a primary alcohol. Can you recognize why? It's because the carbon that is attached to the OH has only one other carbon attached to it. Here's another addition reaction. Not so easy to see this time. If you react an alkene with potassium permanganate, you'll get what's called a diol. It's an alkane with two OH groups attached to it. So sometimes you see this written MnO4-OH-. In other words, it happens under alkaline conditions. I guess that's a better way to write it because you can see where the OHs come from then. Addition reaction because a CC double bond has been replaced by a CC single bond. Here's another type of addition reaction. This is making a plastic or a polymer. You've heard of polyethylene or polythene, make bags out of it, plastic ice cream containers and so forth. You make a polyethylene by reacting ethene with ethene with ethene with ethene. In other words, ethene reacting with many molecules like of itself to form a very long chain. And the long chain has just got CC single bonds in it. The molecules that you make the polymer out of are called monomers. And what you're making is a polymer. Here's another addition polymerization reaction. This time it's propene molecules adding to themselves, making a very, very long chain, this time called polypropylene, polypropene. You can also make PVC this way. You start off with chloroethene, react chloroethene with itself many times. You get the polymer called polyvinyl chloride or PVC.